Welcome to this comprehensive masterclass on Amazon Redshift. Whether you are a beginner or have some experience with Redshift, this video will take you from the basics to an advanced level. By the end, you will be confident in designing and optimizing Redshift workloads efficiently. Before we dive in, I would like to take a minute and to introduce myself. I'm Nitin Srivastav, working professionally as a data architect. I have 16 plus years of experience in building and delivering data analytics solutions. And for the last 7 years, I've been working extensively on AWS. So if I'm talking about Amazon Redshift, you can trust me, I know what I'm saying. Without any ado, let's dive in. So what is Amazon Redshift? Amazon Redshift is a fully managed petabyte scale data warehouse service in AWS. It allows organization to store data and perform fast queries using SQL. So just remember, it's a managed data warehouse and you use SQL for your analytics needs. But how is Redshift different from traditional databases? Let's compare OLAP versus OLTP first, and then we will compare it with traditional data warehouses. So Redshift is an OLAP, which is online analytical processing system, which is designed for large-scale analytics and reporting. It is optimized for aggregations, complex joins, and columnar storage. In contrast, OLTP, which is online transaction processing databases like MySQL or PostgreSQLs, they handle transactional workloads with frequent insert, updates, and deletes. So which database system should you use for your project? You use Redshift, which is ideal for large-scale analytics and reporting with complex aggregation, and you use OLTP system, which is suitable for projects with frequent transactional updates. Some of the key differences in OLAP and OLTP systems I have observed over the years is now most of the OLAP systems support columnar storage format. They are optimized for running heavy workloads, SQL queries, and they are analytically data focused. Whereas OLTP, most of them follow the row-based storage format. They support read-write heavy transactions, and they are primarily focused on the transactional data. So this is the table summary. You can compare OLAP, which is Redshift, with OLTP, which is typically MySQL, PostgreSQL, and other databases. Before Redshift, companies used expensive on-premise data warehouse systems like Teradata, Oracle, Netezza, but these solutions required heavy infrastructure investment upfront and an ongoing maintenance cost as well. Now, Redshift changes the game by offering a fully managed cloud-based data warehouse, eliminating hardware cost and providing seamless scalability. So now when comparing Redshift with traditional data warehouses, these are the four key benefits you can see: scalability, cost effectiveness, performance, and integration. So scalability, Redshift gives you the flexibility to scale your clusters up and down as needed. Whereas in traditional data warehouses, these were the fixed infrastructure. You cannot scale up or scale down so easily. If you have to scale up your traditional data warehouse on-premises clusters, you have to order a new cluster and that will take months to be delivered. Redshift is cost effective. It follows the pay-as-you-go model, and there is an option for reserve instances, which can save you up to 70% of the cost. Redshift is highly performant. So it uses MPP architecture to support fast SQL queries and integration with other AWS services like S3, AWS Glue, and QuickSight for reporting makes it a very good data warehouse choice. Before we proceed to our first hands-on exercise of creating a Redshift cluster and running our first SQL query, I want to take a moment and talk about Redshift pricing model as well. So there are three possibilities when it comes to Redshift pricing. The first is on-demand pricing model. This is flexible pay-per-you-go model. So it is suitable for short-term use case, which I'm going to do right now. So whenever you need a Redshift cluster, you use an on-demand node and you create cluster for using it. It is slightly expensive compared to the reserve instances. So in reserve instances, you make a long-term commitment with significant cost savings up to 70% for consistent workloads. So if you are sure that you're going to use Redshift for the next few years, you can reserve your instances for 1 year or 3 year, and you will get heavy discount on the reserve instances compared to on-demand pricing. The third option, which is recently introduced, is Redshift serverless. So it automatically scales up with the usage, ideal for variable workloads and without any cluster management. So Redshift in itself is a managed data warehouse, but Redshift serverless, you don't even have to manage anything. It's like completely serverless. So if this is clear to you, we'll switch to our first hands-on exercise of creating an Amazon Redshift cluster, and we'll run our first SQL query. So let me log in into my AWS console, and then we'll begin. So I've logged in into my AWS account, and this is the homepage of Amazon Redshift service. So what we are going to do is we are going to create a cluster. So there is a Redshift serverless option, which we'll explore later. But for now, as part of this demo, I want to create a provision cluster. So let me click here. And you see here right now, I don't have any clusters with me. So what I will do is I will click on create cluster. Let me close this for better and give a name ETL SQL demo Redshift. Choose the size of the cluster. So I will go with the one which is just heads up. Most of the enterprises are using RA3 nodes now because of the advantages. The storage and the compute are independent, and it enables data sharing. So there are a lot of benefits when you switch to RA3 nodes. But as part of this demo, I'll go with DC2 because be mindful, Redshift is a paid service. So I will be paying some. So I will go with the most economical node, which is DC2 large in this case, and the minimum number of nodes I will make it. Let's keep it 2 because later on I have to explain the slices and the different nodes. If I just choose one node, in that case, the leader node and the compute node both will be the same. And in the next section, when we are talking about the architecture, I want you to visualize that, okay, how many nodes are there and how many slices are there. So I'll keep 2. It will cost a little bit more, but it will help us in understanding better. So DC2 large and 2 nodes. This is the monthly cost. So these are the on demand pricing. As I mentioned earlier, I will show you the reserve instances pricing as well in some time. Do we want to load some sample data? So let's load some sample data. No problem with that. I will keep the user as ETL SQL user. And there are different options how you want to set up your password. In this case, I will generate a password. I will copy it. I'll paste it somewhere. And don't worry, because by the time you will see this video, I would have already decommissioned this Redshift cluster. So I am not worried about that. Let me just copy and paste it, the password somewhere. So ETL SQL user is the username. Okay, so I have copied the username and password for reference. Now choose a key type. Basically, for in this case, for encryption purpose, you can either use AWS owned key or you can use a customer managed key. We'll keep it as AWS owned key. Now the cluster permission. So you have to associate a IAM role. So this is the IAM role which is associated with this. I will, so let me do one thing. I will remove this IAM role and I will create a new IAM role. And right now, I'll keep it like this, a blank IAM role as default. So this is IAM role it has created, 111405. Additional configurations. Let me disable this so that you can go through one by one each option. So in network and security, I'll keep the VPC as default. Security group also the default security group. Subnet, everything I'm keeping it as default only. I don't have any preference for availability zone, so it's okay. If you are creating a private, if you're creating a Redshift in a private VPC, then you may have to enable this because you may have to do VPC peering, and that's how you will connect with your Redshift cluster. But I will keep it as off, publicly accessible. If you want to access your Redshift cluster, say via your local desktop or something like a local SQL editor from your desktop, you may have to turn it on. And then in your security group, you have to configure that, okay, how you want to grant access to your Redshift cluster. I will keep it off for now, and I'll not enable it in your production cluster or in your workplace. I believe that mostly you will keep it off. You will not enable public access to your Redshift cluster. It's a big security risk. So I don't think any enterprise will allow you to keep it on. Now let's look into database configuration. This will be the default database name. This is the default port. This is the parameter group. I'll keep it as default only. Redshift does require a mandatory maintenance window of around 30 minutes. So every week, if there is a new patch available for your Redshift cluster, in that maintenance window, it will restart your Redshift cluster if required and will deploy the new patch. So it is mandatory to have a maintenance window for your Redshift cluster. Do you want to enable CloudWatch alarm? I can create some alarms also here. Say my disk usage is more than 70% or 80%, then I want to create an SNS topic. Okay, the disk is going beyond 70%. So you may get you can create an SNS topic, and then you can either send an email stating that, okay, the disk utilization is more than 70%, so you can increase the number of nodes or delete some of the data which is not required anymore, clean up some backup tables, something like that, right? So I'll keep it as no alarms for now. And then there is a backup option. So by default, Redshift will take automatic snapshot every 8 hours if there is no data change, and if there is a data change, then it will create automatic snapshot after every few GBs of changes. And how many snapshot to retain, how long you want to retain the manual ones, and then whether you want a cross-region support. So I'll keep all these values as default. I've just set the username, password, created an IAM role, and that's it. So what I will do is I will click on create cluster, and this will take some time to come up, roughly around 20 to 30 minutes to come up. But in the meantime, what I want to show you is this reserve nodes. We talked about reserve nodes, right? And you can have a reserve nodes here. I'm not going to purchase it, but you can choose what kind of node you want, and then you can choose either for 1 year or 3 year. It's a commitment, and then you choose whether you want to pay it upfront or no upfront. And you can get around 70% of saving if you go for 3 years, and depending on your node types, right? So this is a good option. As soon as you have reserved nodes, you come here in the clusters, and in the clusters you can see if you are using reserved nodes, you can see that information here as well, right? So right now my cluster is still coming up. Once it has come up, then we'll see. So I'll pause the video for now, and once the cluster is up, we'll resume. Okay, the cluster has come up. I can see it. It took around 10 to 15 minutes for it to come. So next, our cluster is ready. Next, what I want to do is I want to run a sample query. So, okay, and I will connect to this. I can use the same username and password, which I just now created. So I am connected now. What I will do is I will create a dummy table. It's saying the sales already exist. So let me just give some other name, sales demo. The table is created. Let me insert some sample values into this table. And now let me run this query. So you can see I am able to create a Redshift cluster, connect to it, and then I created a table, inserted some sample records, and query it. So this is it I want to cover in this section. In the next section, we'll talk about Amazon Redshift architecture. We'll see how it works as a massively parallel processing system and how the nodes and the slices play a role in data distribution. Yeah, and if you are liking this video, please like the button, subscribe to the channel if you are new, and drop your comments with your feedback. I read all your comments very sincerely. In this chapter, we will take a deep dive into the Redshift architecture and understand how it processes queries efficiently. By the end of this lesson, you will have a solid grasp of how Redshift is built and optimized for analytical workloads. So let's get started. Amazon Redshift follows a massively parallel processing architecture which allows it to distribute and process large volume of data efficiently. The architecture consists of three main components: the client applications like BI tools, ETL scripts, SQL queries, and dashboards; the leader node, which manages query planning and coordination; and the compute nodes, which executes queries and stores data. So, what are type of nodes in a Redshift cluster? Now, when somebody talks about nodes in Redshift cluster, they may be referring to the type of compute nodes like RA3, DC2, or DS. However, when we are talking about Redshift architecture, there are two types of nodes. One is leader node and the other is compute node. So what does the leader node do? It manages query coordination and optimization. It passes SQL queries and create execution plans, and it sends query steps to the compute nodes. So what do compute nodes do? They execute queries in parallel, store data in columnar format, and return results to the leader node. And what are slices in compute nodes? Slices are responsible for processing a subset of data in parallel. So if you can see here, the architecture, we have a leader node. Leader node, there is just one leader node in Redshift architecture, whereas the compute nodes can be one or many. Each compute node can have one or many slice nodes. And slice nodes are the smallest computing unit which has its own disk. So memory plus disk forms a slice. A compute node can have multiple slices in it. So if this is clear to you, let's talk about the columnar database. So unlike traditional databases that store data in row-based format, Redshift uses columnar storage, meaning data is stored column by column instead of row by row. And this improves performance for analytical queries that process large data sets. So you can see here, I have a table employee with 3 columns in it, name, city, and age, and there are 3 rows in this table. If it is a row-oriented database storage, row first will be stored first in first storage block, row 2 will be stored next to it, and then row 3 is stored next to it. Now, if my SQL query is select name from employee, in that case, I have to read this storage block entirely, then read this storage block entirely, and then read this storage block entirely, and then discard the column city and age to read only name, and then return the result to the user. And this is highly inefficient because there is a lot of IO in it. Even when you have to read just one column, which is name in this case, you end up reading all the 3 columns because the rows are stored together. Now have a look at the column oriented database, which in this case is Redshift. So it stores all the column values together. So if I'm running a query, select name from employee, I will just read this storage block and this will return me all the column names. And I don't have to read column 2 and column 3. So you can see how efficient it is. So columns are stored in same or adjacent block. This allows efficient read when few columns are required. And since all the column data types are together, you can have better compression. Or say in this case, all the varchar columns are together. So you can apply a compression technique which is highly optimized for handling string values. In this case, we have a numbers. So maybe you can apply a different encoding algorithm here to apply highly optimized compression for number values. Better the encoding algorithm, better the compression, more rows can be accommodated in the same storage block. And in Redshift, we have a storage block of 1 MB, which is very big and it can accommodate more number of rows. So what are the advantages of columnar storage over row-based storage? It allows efficient compression, less disk IO, and faster data processing. Whereas in row-based storage, it has less efficient compression technique, it takes more disk IO, and slower disk processing for OLAP queries. If this is clear to you, I would like to talk about the distribution styles in Redshift as well. So to ensure optimal performance, Redshift distributes data across nodes using different distribution styles. Choosing the right style is crucial to minimize data movement and improve query performance. The first one is the key distribution. So here you use a key column to distribute rows. Typically, the column which has the unique values is preferred as the key column, and it is ideal for the fact tables that need to be joined frequently. The next distribution type is even. So this is a default mode also, and it distributes rows evenly across the slices using a round robin fashion. And it is best for tables that does not participate in joins frequently and there is no clear unique key available in the table. The third option is all distribution. So the entire table is replicated across all node. This is best for small lookup tables used in joins. So you can see here I have the employee table with 4 rows and 3 columns. And you can see when I use the key, here I'm using name as my key column. So the first value mark goes to slice 3, second goes to slice 1, and third and fourth goes to slice 2. So this distribution key column goes through a hashing algorithm that determines which slice will hold this value. Looking at the all distribution, all the table content is going into all the slices. So if the table is very big, this will end up having a lot of storage space. So it is not preferred for big table. Only for a small lookup table or reference table, you can go ahead with the all distribution style. And the even one, just randomly on round robin fashion, it will push data across all the slices, making sure that the distribution is even. But since there is no key, there are high chances if such tables are used in joins, there will be some redistribution at the runtime. So in this case, the row 1 will go to slice 1, then slice 2, then slice 3, and then again slice 1. So that's how rows are distributed in Redshift. I want to add one more point. In distribution style, you also have option auto, which starts with all and then switches to even as the table size grows. I will suggest you to refrain from using auto option. Either use key, all, or even. Don't use auto. And the problem here is it starts with all, but as the table size grows, it switches to even distribution style automatically. But if the table is truncated or the data has gone down again, it will stay as even only. It will not revert to all. So my suggestion is refrain from using the auto, use key, all, or even distribution style. So which Redshift distribution style should you use? Use even distribution, which is best for tables without unique keys and not frequently used in joins. So this ensures that even data is distributed across slices. Use key distribution, which is ideal for fact tables that have a clear unique keys and which are needed in joins frequently. And use all distribution, which is suitable for small lookup or reference tables, which are used in joins as well. This replicates the entire table across all nodes. If this is clear, let's move to the next slide. The last section of this lesson, I want to cover how exactly the SQL query execution happens in Redshift. So at the very first step, the user submits the query, and this query it can be via BI tool or an SQL editor or an SQL script. The leader node receives the query and it analyzes it. It creates the execution plan, and then it passes the query steps to compute nodes. And the compute node executes those steps accordingly in parallel, and then the compute nodes send the result back to the leader node, which collate the information and give it back to the user. So that's how the Redshift architecture works, and it makes sure using MPP system and columnar database and distribution style that your SQL query executes in a very efficient manner. So this is it I want to cover in this lesson. Hope now you understand how Redshift follows an MPP architecture with leader and compute nodes. Data is stored in a columnar format for faster query execution. Choosing the right distribution style is very important and it improves performance of your SQL query. Queries follow a step-by-step execution process using MPP style. So if this is clear, see you in the next chapter.